really just about technology. It's also about the teams and the people that make up the technology.
Something so different. Something so different.
My name's Adam Nelson. I just wanted to thank you all for coming. I think you should all look around. You're probably the most innovative, forward-thinking development and operations professionals in Nairobi. So this is a good chance for you to think well of yourselves, but also to meet other people who are also in the same situation and create relationships, because I think some of you probably work at good organizations and are looking to hire people, and some of those people might be here that you could hire, and vice versa. I think some of you probably work at crappy organizations and you should be leaving those organizations and finding the people that work for great organizations and working for them. So I'm going to talk about continuous integration and what it is and what it's about. When people talk about DevOps Day, they think about, that's good. So they think about DevOps as this concept of, oh, how do I roll out my code specifically, or how do I get my code live, or how do I maintain this legacy system? So I've got an SAP banking application that hasn't been updated in 6 years, and it's, but those are all kind of big picture things, and those are all part of the big giant DevOps movement. But there's something a little, there's a piece of that which I'd like to talk about right now, which is continuous integration. Continuous integration can be applied on multiple different levels. So most people think about it as, how do you get all your code integrated within a development team so that everybody sees your code very quickly and you don't have a lot of problems in the future and inefficiencies around your code branching off and not being visible to other people. But I'd like to expand it and talk about not just code, but libraries and packages as well. How do you get your libraries and packages constantly moving forward so that you don't have as many problems with your production operation environment? So I'm just going to give a simple definition, really, of continuous integration, and that definition is having your code and your libraries and your packages all coalescing around some sort of master branch, and all your operational resources using that master branch. This doesn't actually have to be an actual master branch. It doesn't have to be a master branch that is even part of the repository. It could actually just be that you're using SAS 6.0 or whatever, and you're just following SAS down the line. You don't even have a code base, but just the fact that you're upgrading regularly and that all your environments, let's say you have a staging environment for your Oracle or SAS or SAP project, just the fact that you're moving all your environments forward in sync, in a serial way, I think that in essence is kind of the very small way of thinking about continuous integration and how you do that stuff. It also means, in my mind, continuous integration, that you take changes from different developers and you allow them to propagate upstream quickly and also to each other quickly without a lot of intermediary time. So that's this. But by the way, this can be a very conversational talk, because I think a lot of people, is anybody doing continuous integration now? Okay. Anybody else? Yeah? How do you do continuous integration?
I manage online solutions for customers.
Yeah.
Which require time-to-time updates in terms of configuration.
Yeah, okay.
Say the business tool, so the business may add a product.
Yeah.
Or they may label certain service.
Mm-hmm.
So you have to make modifications to the configuration to store that, so then deploy it.
Yeah.
Stage it and deploy it.
And
So,
do you have a team of more than one person?
yes.
Okay.
But to be honest, we run it on a global scale.
Yeah.
So we have a team responsible for configuration. Another team responsible for deployment.
Right.
So once we've done the configuration, we've ascertained it's working.
Yeah.
We only request deploy to production.
Okay. Yeah, so continuous integration is a spectrum of different ways of thinking about things. And I think all the definitions that we're going to talk about today, there's no single definition, and it's not like everybody's perfect and everybody follows every possible forward-thinking way of doing all these things. So, it's a spectrum, and you can start doing any of these tasks just from nothing. Yeah, so there's also something called continuous deployment, which is kind of like what you're talking about there. We're not really going to talk about continuous deployment today. But continuous deployment is where you make all your integrations and you make all your changes, and then you deploy them continuously. Yeah, so we're not going to talk about that. Version control. So this always gets glossed over, but I think it's absolutely critical that we talk about version control. Who is not using version control here for a code project that they're doing? Okay, I know you don't want to admit it. So who here is using version control for something, some sort of code base? Okay. Okay, we got a couple. So there are groups not using version control, and I just want to tell you right now, just stop and start using version control. Version control is basically one of the core key components of allowing you to do continuous integration. And some people try to jump ahead and do other stuff without version control, but you absolutely can't do anything else without version control. Version control is what allows you to maybe just make sure that the vent is. So continuous integration makes sure that you can take different changes from different developers and allow those developers to, version control, allow those developers to make changes, and then the next developer can make another change, and you can see each other's changes through some sort of shared repository, which is where all the code lives. And the code isn't just code, it's also configuration variables, it can be status of the machine, it can be package version numbers, it can be library numbers. So even if you're just running a fleet of a couple of Ubuntu servers, it's probably wise to have some sort of version control around what packages you're actually using and what those version numbers are. Just so that you can communicate with each other and always make sure that you're not updating one version of Ubuntu with not updating the other version. So because I'm kind of an opinionated person, I'm just going to tell you what to use. Git and Mercurial are the only two real options. There's some outdated ones that people used to use, like CVS. The version used to be great. It was so far ahead of its time, but now it's outdated. And there's Visual Source Safe, which I think is just totally dead at this point. So you really should choose Git or Mercurial, and then you should basically just use Git. Is anybody here using Git? Okay. If you are using Git, a lot of people here use Bitbucket. I personally think GitHub is far superior, so I would recommend using GitHub. And if you are afraid of the price of GitHub, just open source your project, because if you can't afford to pay for private repository, your project probably isn't so valuable that you can't just open source it. And if you do open source it, that's great, because then that's a good way to recruit people, that's a good way to find other people interested in other projects, it's a good way to get contributions to your code, it's a good way to also be confident in your code, because in order for your code to be public, you'll probably feel a little more embarrassed about low quality code than you might if it was private. So I highly recommend just getting on GitHub, just making your code public, and not worrying so much about your code. Just get it out there. So here's the whole rationale for continuous integration. Here's the time between developers' branches. So that's like you've got 2-3 developers, and they're doing whatever work, and one's working on the registration system, and one is working on the authentication system, and one is working on the monitoring system, and all of a sudden they try to merge their changes, but they've all been changing the user system. And all of a sudden you end up in what's called merge hell. How many people have been in merge hell before? Okay, got a couple people in merge hell. Okay, so it's good if you haven't been in merge hell, although it's probably a sign you haven't worked on a large enough team. But I think you can get in merge hell even with 3 developers. Is probably the minimum of which merge hell can happen. But even 2 developers, it can happen. Okay, good. So integrate early and integrate often. This is another concept for continuous integration. When you have your changes, this very simple solution is just to have a single branch. It's called master. Don't have any other branches. Everything goes to the master branch, and everybody is pulling literally multiple times a day. And certainly, if you're pushing, you're going to have to pull because you can't push unless you pull the most recent changes. That's true even in Git. Okay? So, hopefully. But then here's the classic complaint. So, before the complaint was, oh, it worked on my machine or it worked in my environment, and now it doesn't work. So now it's an operations problem, not a development problem. And this is always the complaint, which is that there's some developer on the team who's writing crappy code, and that crappy code ends up on somebody's else's environment, and then all of a sudden they can't work anymore. So you've got a couple of issues with this happening. So the first is, if Johnny developer is really writing bad code frequently, you need to sit down with that person and maybe pair with that person so you can actually have cohesive programming together. That's the best way to actually do continuous integrations, not even have two developers, but just to have one pair. But the other situation here is, there we can increment to the next slide, is unit tests. Because unit tests are really the fundamental building block beyond version control that allows people to have a continuous integration environment. First, you need version control. Second, you need unit tests. Unit tests allow you to test. Well, first of all, let's talk about unit tests. First of all, unit tests are fast. They take seconds, not minutes. Second of all, they really should not have external I/O. So no database interactions, no real writes to the caching mechanism, none of that stuff. And they should. Atomic is really a strong word here, but they should not be overflowing into multiple different classes. So you want to be testing one class at a time with a unit test. A unit test is a test of a unit. And a unit, typically in object-oriented programming, is a class, although it could be a method or something. So if you've got what you think is a unit test and you're testing 8 different classes, and the fact that a piece of data moves through all 8 different units, that's not a unit test. That would be an integration test. So we can move to the next one. Code linting. Does anybody know what the word lint means in code terminal software? So linting is, I didn't actually know this before, but it's like when you go to a sheep and you take the wool off, there's the lint that comes off, and that's all kind of the stuff that's not really useful. So code linting means that you go through the code base, you look at the code statically, you don't actually do any real interpretation. So if it's Python, you're not actually running Python in order to do the linting. If it's C, you're not actually running C in order to do the linting. And you're not actually using those programs. You're not putting variables in and seeing how they come out. You're literally just looking for code quality based on a style guide and based on some rules, essentially, very simple rules, like no 2 lines should look exactly the same in a row. That could have helped with some certain security flaws or something. If you're in Python, you want to make sure that every indent is 4 spaces and not a tab or not 8 spaces. And if you're in other languages, there's just a whole bunch of rules around how they should be written, and those rules can be evaluated very, 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 very fast through linting to make sure that everything works. So in my opinion, a good continuous integration environment is going to have a linter involved at some stage in the process. Hopefully, frequently or all the time. You can even get it if you're running an integrated development environment, or even certain plugins from certain editors. You can have it lint in real time, and you can actually have it. It'll give you a little warning that says, "This is not proper Python code," or "This is bad style." That's what I love about Python. Is Python has a style. It's called pep8, and if that style is not really negotiable. That style is global, it's universal. Everybody in the world accepts pep8 if they're programming in Python as the style guide. So it's not like PHP where you can have an argument about whether you should be using 4 spaces or a tab or something like that. The Python community has decided what the grammar is, and I think that makes a lot of sense because if you're talking about a language, it's best if the grammar is agreed upon. Okay, we can go to the next slide. The best way to implement this stuff is with a pre-commit hook. Pre-commit hooks, well, I'll tell you how they work. If you're using a version control environment, and you're using unit tests, and you're using linters, you can very simply create a pre-commit hook. And the pre-commit hook is just a matter of the developer does some work, he or she changes, let's say, 40 lines of code. All of a sudden, he or she tries to commit. before the commit can actually run, the pre-commit runs in that person's development environment, and it does two things. One is it runs the unit tests, and the other is it runs the linter. The unit tests, again, should take seconds, the linter should take seconds, and then you're in a scenario where if there's a failure in either of those two steps, a warning will be shown to the developer, and the commit will not be allowed to go forward unless the developer actively bypasses it for some reason. So all of a sudden, you're in the scenario where Johnny developer's code is significantly less likely to break Jackie developer's code. You can have two developers working together or four developers on two pairs, and they can make changes, and the confidence level of that code quality goes much, much higher, easily from 20% to 90%. So if you're getting code from your other developers that's breaking your build frequently, it's a clear sign that you need unit tests and linting, and you need those things to be enforced, and the way to enforce them is with pre-commit. This kind of leads to a smaller question, which is how big should a commit be, which I'm often asked. So there's no hard and fast rule here, but you want a code commit that's big enough to get an actual task done. So it can't be half a task. So let's say you need to, the story that you're trying to do is to allow somebody to enter your first name into the user profile. You probably wouldn't want a commit that's so small that you're just changing the form that allows them to add the first name. You probably want to have a commit that's big enough that they can put the first name into the form, and then the form actually puts the first name into the database. That would be the right size commit in that scenario. But not bigger. So if it's also like you're going to have some special page where you show the first name, you might want to have that be two separate commits. Now, when you do these, each of those units needs a unit test. Unit tests can be really, really simple, and you can take a lot of shortcuts, and you can make a lot of just obvious things there. So let's say you're doing a unit test with the first name, and the variable is just called first name, and you want to test whether first name actually makes it into the class properly. You might mock some sort of, well, you wouldn't mock it, but you would have a variable for first name, and that first name might be Adam. And you're doing the test to make sure it works. So you don't have to use a first name that's written in Chinese characters or Arabic or something like that. That would be the more aggressive way to do the unit test. Is first you do the first name Adam, and then you do the second name, first name with Chinese characters to make sure Unicode works, and then you do a first name with like an accent or something like that. You could do all that stuff, but I think if you're just starting, just come up with the easiest possible way to get the unit test done and just do it. Okay. Bugs. This is a little bit of a diversion from the continuous integration path, but I think it's really critical to continuous integration. Because if you do have bugs, and they are on the live site, those bugs will propagate sooner or later back into a bigger bug, or into a bug that another developer experiences while developing some other piece of code. So if you have a bug where a Unicode first name blows up the system, you need to make a decision pretty quickly. First of all, you need to document the bug and see if it causes an obvious exception that you can read, so it's very easy to make a fix. Second is you need to put it right to the top of the list of things to do, so bugs first. Third is if the bug is, if you're in the middle of working on a feature and you're not done with the feature, you should finish what you're doing. But once you're done with the feature and you're going to the top of the stack of stories to do, you really want to do the bug next. If you all say, like, this bug is so stupid, it's never really going to happen, it's not really a real bug, just delete it. Nobody likes to hear that, but if you have bugs that nobody cares enough about to actually fix, they're probably not that important, and rather than just letting sit there and confusing yourself, just delete them. But if you are going to fix them at all, fix them quickly and fix them first. And the most important thing about bugs is that we can find a bug to write a unit test for that bug. Ideally, if it's a unit-based bug. If it's not, you'll have to do an integration test. But then you can get those unit tests, and then 2 weeks later, when somebody's about to write code that makes the same mistake, like they don't handle Unicode in some string, you've got a unit test to make sure that if that's happening in the first name class, that bug will get caught, because when the person goes to the pre-commit hook, unit tests run, the regression hits, they get a failure on a previous bug, and then that's it. That commit won't go through, and that bug won't go live again. What's also great about bugs is that they give you a real kind of phenomenological entry point into an actual real-world bug and an actual real-world unit test, because there's nothing easier to write a unit test for than an actual bug with actual reproducibility. So if somebody's putting in an actual name that actually causes an actual problem, you can just literally copy and paste that name, put it into the unit test, and boom, you've got a better unit test. And you didn't have to do any work. You just took a bug that somebody found on your website. Okay, I'm getting that slide. This leads to integration tests. Integration tests are not unit tests. So when you're doing continuous integration, you need to worry about not just these small little things like, can your class handle the Unicode first name, but can that Unicode first name go all the way through the process? Can it be written at the cache layer? Can it be written at the database layer? Can it be read from the database layer? And the best way to solve that scenario is to use integration tests. And integration tests do not run in seconds, they take longer, especially in a large complex environment. So you can't really expect the developer to run all the integration tests every single time where she commits. So there's two scenarios. One is you write the integration test, which actually mocks up certain data parameters around moving the data through different classes. And then you also get those tests to run. And then if the developer makes changes on a part of the class where it's very obvious that it could have a negative impact on the functionality of the system, he or she shouldn't trust just the unit test. He or she should manually run the whole integration suite. But since he or she might not do that, you also want to run the integration tests on you can go to this, on a build server. So a build server is what allows you to run integration tests repeatedly on every single commit. So even though the integration tests might take 5 or 6 minutes or 20 minutes, you can run them on a server without making a developer wait 20 minutes to figure out if their code works or not. So now you're getting to a more advanced situation, which is developer makes a code change. First of all, a version control system. Developer makes a code change. Unit tests run on that change. The linter runs on that change. If everything passes, it goes up to the commit Git repository. Now the Git repository, if you're using GitHub, it's got a very simple webhook interface. On post receive hook runs, and then we'll signal the webhook of your continuous integration server to say start running the integration tests based on this commit, and it'll start running and running and running. Now, developers aren't getting push notifications typically of new commits. It's more of a pull process. So let's say you're doing 45 minutes worth of work on getting a new ticket done, and somebody else is doing 45 minutes of work getting a ticket done. They do the commit 20 minutes into your work, so you're probably not going to do a pull and a push for another 25 minutes. In that 25 minutes, the build server runs, goes through the integration tests, sees that there's a failure, and notifies everybody on the team about the failure. Ideally, the person who created the failure sees it very quickly, fixes it, and potentially even fixes it before the other developer does the pull and has that problem. In addition, the other developer now knows that the build is broken and to be a little suspect. So this is a good way to take advantage of the fact, or it's kind of like a halfway point, because you can't have all your tests run in 2 seconds if it's complex. But you do know that developers aren't working in 2-second increments either. So if a developer is working in a 3 or 4 hour increment, there's a good chance that the developer can keep on working. The build gets broken, the third developer fixes the build, and that all happens before the other developer does the pull and the push, and everything is good. So this is kind of an extension on the bugs first mentality. It's not just the bugs first on the live side, it's also the bugs first on your master branch. So you should really change granularity. So I'll be opinionated again, there's only really 2 build servers. I don't know, does SolidWorks have a build server that you guys use?
SnapCI, Java.
Okay, do you recommend it?
Yeah.
Okay. All right, so I'll take it on word that it's good, because ThoughtWorks is generally good generally. So there's Jenkins, Travis, and then the ThoughtWorks one, which you can Google. It's like ThoughtWorks CI or something. What is it? Go. Go might be hard to Google though. Yeah, you gotta rename that.
But there's also SnapCI, which is like a lot more like Travis.
Say again?
SnapCI.
Okay.
Yes, it's a lot more like Travis.
So it's more like Travis. Okay. And then the project we work on uses OpenStack, uses Jenkins. I don't know why. I'm trying to convince him that Travis is kind of cool, but it's a very diverse, large project, and I think there's a lot of enterprise people there, so they probably want to. They've got a lot of special requirements, so maybe they don't feel like Travis can do what they need to do. I don't know. So is anybody using a continuous integration server here? Okay. Or are you kind of using one? Are you go? Okay. All right. We can go to the next one. Okay. So I lied a little bit. I think I do want to talk about continuous deployment because I think it's kind of a useful topic. So even though nobody's doing continuous integration here yet, I'm confident that in the next 6 months, somebody will be doing it doing it now. And so I want to talk a little bit about continuous deployment so you know what the end goal is of continuous integration. Not that you need to do continuous deployment in order to get huge benefits of continuous integration. I would go so far as to say that continuous integration is the 80 for the 20. For 20% of the work, you're going to get 80% of the value. And then continuous deployment is the next logical step. You certainly don't have to go down a continuous deployment path yet. So we can go to the next slide. So the first thing, this is a real easy thing to do, and I really like doing it for continuous deployment. It's called feature flipping. And what this allows you to do is to isolate your code deployments from your feature rollouts. So let's say you decide to have a new feature where somebody adds their first name to their profile and then gets it out of their profile, or that first name is now used in emails that are sent to those people. What's nice is what you can do is you can do all your continuous integration. You've got a version control system, you've got multiple developers, you've got unit tests, you've got linting. As you commit, you've got integration tests running. On failure, you get a build failure comment. All that's happening, and now you're deploying. But you can deploy without turning the feature on. So usually, strategically, you can put a little if statement, and there's even little libraries that handle this very effectively for you, to only have that feature available when you turn it on. What that means is that you can get your code live, you can run your migrations to create a first name column in your database, you can get your templates out there so that the first name variable gets inspected by production code. You can have all that code looked at except for a small chunk of code, which actually turned on feature, so that it gets a little bit of exercise. So let's say all of a sudden you turn on the fact that the first name is going into the cache, but you're not actually using the first name yet, and then you realize, oh, the first name is causing cache problems. You can actually see that before you've enabled the feature itself by using feature flipping. So every good web framework that I know of has a feature flipping library. Django has 2 or 3. Rails, I know, has 2 or 3. This is critical, and this is why also if you're programming for the web, you need to use the web framework, because these types of things are available. And they're really not difficult. Literally for Django, you can just install this library, look at the documentation for how to run it, and I guarantee you within 2-3 hours you can implement feature flipping on your Django website if you're using Django. It's blazingly simple. And then the feature flipping happens through the database, which is even cooler, which means you can turn on and off a feature if you set it up in your code dynamically through the database without even having to do code. It's also very effective. It's not a performance problem typically because if your database is cached, and this just becomes a little tiny variable. It's not even cache numbers, so it's not a big deal. More advanced deployments can do things like they'll deploy without the feature active at all. Then they'll deploy it to just people within their inner community. So Facebook does this, where when they do a deployment, that deployment, they do a deployment, and then when they make the feature active, they make the feature active just within the compound. So people in Facebook see the new Facebook, and people outside of Facebook don't. And then they release it to 10% of the population, and then I think it's 50%, and then it's 100%. So huge organizations like Facebook, first of all, huge organizations like Facebook are doing continuous integration. Second of all, they're doing continuous deployment. They're releasing multiple times a day. And so if the largest website in the world can do it, I think any of you guys can do it. You don't need to stress out about the fact that you learned somewhere in school that you need to do 4 months worth of changes and then release every 5 months because you're afraid of so much. Another aspect of continuous deployment, it's a complicated word, but really it just means things like feature filtering. But the next thing is monitoring. If you're finding out about bugs from your end users, that usually means that you're not good at monitoring your system, because you should be able to find bugs from your logs and from your performance monitoring. So if your user's emailing you and saying this doesn't work, that most likely means you're not logging enough and you're not looking for bugs. You should be able to, for the most part, except for some very weird, corner case type bugs, be able to find those bugs proactively by looking in your logs and seeing warning statements and exceptions of actual failures that happen. Investigate all exceptions and log all exceptions. If you have exceptions you're just ignoring, you're not going to be able to do continuous deployment because you're going to have this problem where your system is always a little bit broken, and then if you break it more, it's going to be catastrophic. The whole point of continuous deployment is you're doing small changes rapidly, and then if you have a bug, you know that it happened when it happened because you're monitoring the system. So if you rolled out and then 5 minutes later you start seeing this bug, and then you look at your logs and you realize, oh, it never happened before, you're highly confident that it has to do with the change set that just went out. And since the change set is probably like 30 lines instead of 800 lines, makes it much, much easier. So we're talking about saving time, we're talking about higher quality services, we're talking about a better development environment.